First of all, what's the current situation with the roadways? Well, I don't know if you've seen this report yet, but according to the Road Information Program, a non-profit organization that studies highway issues, of major U.S. metropolitan areas greater than 50,000 or 500,000 people, California has 6 of the 10 worst roadway metro networks. LA is number 2, with nearly 2/3 of its roads, major roadways, in poor condition. In fact, only 5% are considered to be in good condition. So while poor quality roads cost the average American a little over $400 a year, living in the LA area costs motorists an additional $746 annually for increased maintenance costs, increased fuel consumption, and tire wear. Our highways are expected to become busier, as over the next few years, light vehicle traffic is expected to increase 35% and truck traffic by 64% by the year 2030. So it shouldn't surprise us if roadway conditions worsen in the future due to the local budget constraints. Turns out that bad roads are also bad for your health. A recent study found that roadway conditions were a contributing factor in more than half of the nearly 42,000 deaths resulting from motor vehicle crashes each year, and 38% of the non-fatal injuries. In terms of crash outcome severity, it's the single most lethal contributing factor, greater than speeding, alcohol use, and non-use of seatbelts. The study also estimated that the cost of bad roads to the U.S. economy is at $217 billion annually. So while we talk about sustainability, usually the focus is on the environment, but in this case, roadway maintenance, economic sustainability is just as important. A study of our state road conditions by the County Engineers Association of California and the League of Cities shows a backlog currently of $37 billion needed in road repair just to bring our system into a condition where it can be maintained using pavement preservation. And this doubles at almost $71 billion backlog in repair and rehabilitation by 2033 if funding stays at current levels. So you're going to see that business as usual clearly isn't getting the job done given the rising cost of materials and shortfall in funding. So is this process really sustainable? And while Tim talked about green roads, we look at it a little simpler way. We call it the 3E challenge. Does it meet engineering, economical, and environmental goals to determine sustainability? Hot mix paving, which uses virgin rock and asphalt cement, is also associated with high energy costs, transportation costs, and emissions. Mill and fill, the process of milling out existing worn-out pavement and replacing it with new hot mix pavement, is currently one of the most popular roadway repair and maintenance strategies. Well, the Federal Highway says we generate about 100 million tons of asphalt a year from milling out old roadways. And while it's the most recycled product on the planet by volume next to water, 80% is recycled back into roadways, but only 15 to 30 goes into new surface overlays, with the balance being used for shoulder backing, road base, or other less valuable uses other than the top lifts of the pavement. Still, at least 20 million tons going to waste and not being utilized, and that recycled asphalt pavement contains valuable aggregate and asphalt. So the old mindset of mill and fill and worse first treatments of our pavement as an answer to keeping roads in good shape really needs to change. In fact, according to a federal highway report recently, agencies can reduce pavement life cycle costs by adopting a pavement preservation approach, emphasizing early repairs to pavement surfaces while they're still in good condition, which reduces the cost of keeping roads smooth by delaying need for costly reconstruction. So we really need to focus on preservation of existing pavements, lowering life cycle costs, while using environmentally friendly processes. So let's think again about the 3E challenge here. Pavement preservation and recycling significantly improves sustainability. Most pavement preservation and thin lift processes utilize asphalt emulsions, which are a mixture of asphalt and water. Emulsions, just to give you a background, emulsions were green before green was even popular. They've been in general use since the 1920s. They're water-based and very energy efficient because they're handled and used at low temperatures. There are little or no emissions with asphalt emulsions. And recent breakthroughs in surfactant technologies, most emulsions are very specialized. They perform specific functions with a wide variety of break and cure times. This keeps user delays and road closures to a minimum and saves agencies and shareholders, us taxpayers, money. So I'd like to show you examples of treatments that are being used by progressive agencies in the area here. The first one is a rejuvenating seal, which are typically applied to pavements in good condition. You see in the high condition area there. It's really a light application of asphalt rejuvenant applied to the surface. It softens the oxidized surface asphalt layer, seals small cracks, prevents loss of surface fines. Kind of puts back into the pavement when sunlight and weather and aging is taken out, almost like a sunscreen for your pavement. It's quick application. We usually restore full traffic in 15 to 2 hours and extends the remaining service life of your asphalt 3 to 5 years at about 1% of the cost of an overlay. Scrub seal and chip seals are used to address minor cracking, rattling, and skid resistance, a little more distress in your pavement. We apply a larger amount of binder, and in this case here, you see this broom. We use a scrub broom to actually treat cracks. It's a mass crack filling system. It's followed by a cover aggregate, which can be either virgin aggregate or recycled asphalt pavement. So it's rolled, and the excess stone is swept off the roadway, and we open traffic at the end of the day. Okay. This distress category here also includes slurry and microsurfacing, which are done by a lot of agencies. These treatments extend the remaining service life for payment 5 to 7 years at a fraction of the cost of an overlay. Cape seals are a little more aggressive treatment for higher levels of distress. They address a greater cracking distress, swallowing, rattling, and really can be considered as corrective maintenance. It's a 2-layer system, with the base layer being the chip or scrub seal we just talked about, that acts as an inner layer and prevents cracking from coming back through. And then we apply a layer of slurry or microsurfacing over the top and on the traffic level. Slurry and microsurfacing are really a mixture of asphalt emulsions and fine-graded aggregates that are applied over the top, and again can be comprised of recycled asphalt pavement instead of virgin aggregates, and yields a rich, smooth black surface that's quite enticing to residential areas. Again, this is a treatment that extends your remaining service life 5 to 9 years at a fraction of the cost of an overlay, maybe 10 to 15% of an overlay. And lastly, for pavements that just aren't suitable for surface treatments, we have cold-in-place recycling, which is a technology that's really been used for about 30 years, but recently the advent of solventless technology, engineered emulsions, and mix design have really increased the reliability and performance of these systems. Again, when surface maintenance is no longer effective is when we go into this full recycling mode. It addresses large thermal cracks, fatigue cracking, potholes, and poor rideability of our pavements. Typically, we recycle to the depth of 3 to 4 inches because of compaction issues. This whole train here that you see mills, crushes, screens, and lays down material in one pass, about 12 to 15,000 feet a day. Okay. Traffic is restored to the surface at the end of the day, so user intrusion is at a minimum. And a final wear course is required on a system like this because of the high waste structure of the recycled mix. Typically, you can use a thin overlay, we can use a chip seal or slurry seal and save the agencies a lot of money. Hot in place and cold central plant recycling are also alternatives, but they're not as green, and we'll show you those here in just a minute. This slide here demonstrates the energy used per ton of material for mixed materials, and as you can see at the top, cold in place recycling emulsion wins hands down. Finally, an example of a progressive agency that's local to us, San Bernardino County, that went from typical mill and fill to a more aggressive, proactive maintenance strategy using treatments that we just talked about. This is the perfect storm that every agency is facing. The red line, being roadway budgets. As you can see, roadway budgets have declined as in many agencies. But because of the change in strategy, they've managed to increase the amount of roadways being treated. That's the green line. Okay? And actually have increased their overall pavement condition index, an index that gives us an idea how good the pavement is, from a poor to a good condition. See, their average pavement condition index increased to 70. All the while materials have increased in cost. That's the yellow dots there. So reduced funding, increase in material, they're actually able to treat more roadways and bring their overall network up to a higher standard. It's just a success story for anybody, so encourage anybody to challenge what they're currently doing. That's my presentation. Thank you.